Section 9.3, graph and write equations of circles. So a circle is the set of all points x, y in a plane that are equidistant, the same distance, from a fixed point called the center of the circle. The distance r between the center and any point x, y on the circle is the radius. The standard equation for a circle with the center at the origin is x squared plus y squared equals r squared. So the center here is 0, 0, and your radius is r. So we're going to graph x squared minus 4 equals negative y squared and identify the radius. So the first thing we want to do is we want to put it in standard form. So I'm going to start by adding 4 to both sides. So now I have x squared equals negative y squared plus 4. And then I'm going to add the y squared to both sides. So now I have x squared plus y squared equals 4. So my center is at the origin, and then r squared equals 4, which means that r equals 2 if we take the square root of both sides. So my center of my circle is at the origin, and then my radius is 2. So from the center, I'm going to go 2 to the right. I'm going to go up 2. I'm going to go 2 to the left. And I'm going to go down 2. And then I'm just going to connect them with a smooth curve to be a circle. Okay, so if we are told that a point lies on a circle, like in this next example, we have the point negative 4, 7. It lies on a circle whose center is the origin. We want to write the standard equation, standard form of the equation of the circle. So the first thing we have to do is find the radius. So we can find the radius using the distance formula. Here's our distance formula again. The square root of x2 minus x1 squared plus y2 minus y1 squared. Our 2 points are going to be the given point and our center, which is 0, 0. So it does not matter which one you start with. I'm going to go ahead and start here with negative 4 for x, and then minus the x coordinate over here, which is 0, squared, plus my y coordinate minus my other y coordinate squared. Negative 4 minus 0 is negative 4. 7 minus 0 is just 7. Negative 4 squared is 16. 7 squared is 49. And then 49 plus 16 is 65. So since the distance, which is our radius, is equal to the square root of 65, but our equation of our circle is going to use r squared, we're going to take the square root of 65 and square it and get that r squared equals 65. Now we can write our equation, x squared plus y squared equals r squared, which is 65. And then we're done. We have our standard form of our equation. Okay, so now we're going to write an equation of the line tangent to the circle. X squared plus y squared equals 61 at the point 5, negative 6. A line that's tangent to the circle is perpendicular to the radius at the point of tangency. So it's perpendicular here, right where it touches the circle. So the radius to the point, so our center is at 0, 0, and then our point is 5, negative 6. So we're going to find the slope of that radius. So slope y2 minus y1 over x2 minus x1. So we're going to take our y's and subtract them, negative 6 minus 0, and then over our x's, 5 minus 0, to get negative 6/5. Since we want to find the equation of this tangent line and it's perpendicular to the radius, we have to take the opposite reciprocal of that slope because perpendicular lines have slopes that are opposite reciprocals. So our perpendicular slope is 5/6. So we flip the fraction and we change the sign. So now we're going to write the equation of the line. We have our point and we have our slope. So I'm going to use y minus y1 equals mx minus x1. I'm going to plug in my points. Y1 is -6. My slope is 5/6. And then my x1 is 5. And then I'm just going to go ahead and leave it here. I'm just going to change this to y plus because y minus a negative is plus. And I'm going to see, actually I'm going to have to distribute it to find the one that matches. So 5/6x minus 25/6 if I have that over 1 and multiply. And then I'm going to have to subtract 6. So first thing I'm going to do is look at my answer choices and know that it cannot be A or D because they don't have the right slope. And so 6 is going to become 36/6. So it's going to become a pretty big negative number, which leads me to guess that it's going to be B, which it is. The regions inside and outside the circle, x squared plus y squared equals r squared, can be described by inequalities. X squared plus y squared is less than r squared is the region inside the circle, and x squared plus y squared is greater than r squared is outside the circle. So if a business owner wants to buy property within a 30-mile radius of the airport, she finds property 10 miles west and 24 miles south of the airport. And we want to know if it's within the 30-mile radius of the airport. So we're going to use x squared plus y squared less than r squared because we want to know if it's inside there. We're going to plug in our x and y. So since 10 miles is west, east and west is going to be your x coordinates, your horizontal distance. And 24 miles south, that's your vertical distance. And we want to know if that's going to be less than our radius is 30 squared. So 10 squared is 100. 24 squared is 576. 30 squared is 900. If we add these together, we get 676, which is less than 900. So our answer is yes. Okay, so then finally, in the previous example, which is this one, suppose the owner drives due east of the property to another property. For how many miles will she be within 30 miles of the airport? So you're going to be at the point on the circle where the y-coordinate is -24, because we're south 24, and the x-coordinate is positive, because we went east. So we're going to have x squared plus -24 squared equals 30 squared. -24 squared is 576. 30 squared is 900. And we're going to solve the Pythagorean theorem. So we're going to subtract 576 to both sides. And x squared is 324. When we take the square root of both sides, we get x equals 18. So since she started 10 miles west, we know, and then she ended up 18 miles east. We're going to do 10 plus 18 to figure out how many miles she traveled. And that's 28 miles.